In this video, you will be going through the different types of exponent rules, and you will need to write these down and have them for a reference. So you see here we have a chart of all different types of rules for our exponents. We're going to go through the list of them, and we're going to actually have some examples later on in the video. So you see the first one right here, where it has a to the m times a to the nth. When we have it where our bases a and a are being multiplied, we add our exponents. And so you can see the example here, x2 times x to the fifth equals x to the seventh. Dividing, when it's written as dividing, you will need to subtract the exponents. So r to the eighth, r to the third equals r to the fifth. So again, 8 minus 3 equals 5. Power to a power, the third one, you have a to the mth times n on the outside. So when it's in this format, you will multiply your two exponents, so m and n in this case. So example, y to the third times 4 is y to the 12th. Power of a product. Okay, so what you're going to do here is the same thing as like the last one, except the only thing difference is you're going to basically like distribute, and you're going to distribute that n to the a and to the b. And so if you see here on the example, 2 to the 4th, not 2 times 4, it's 2 to the 4th, so you get 16. C to the 4th is c to the 4th. Power of a quotient, we have a over b with an n power on the outside. So again, like the last one, we're going to distribute the n to the a and the b. And so then you see our example over here, 5 to the third. You'll actually need to evaluate it, so 125, and then make sure that 3 is applied to the w in the denominator. Okay, and so then that's it on that one. Power of a negative exponent. Anytime you have a power of a negative exponent, especially in this case, we are going to still distribute the n to each one, the a and the b, like it was done in the last example. The difference would be is that once you distribute right here in this step, you will then switch your b and your a, because the only way to make it positive, the exponent's positive, you would have to switch the location of the two. So again, if you look over here in this example, the negative 2 is applied to the x, applied to the negative, or applied to the 5. So it's going to say x to the negative second over 5 to the negative second. But in order to make it the exponents positive, we need to switch it. And so now you see our final answer over here, 5 squared equals, or 5 squared is all over x squared. Okay, and then here's some more negative exponent rules. A to the negative nth, again, making that exponents positive, rewrite it. So this in case will be 1 over a to the nth. Or if the exponent was already negative in the denominator, you will bring it to the numerator and it'll be a to the nth. So our example over here, 3 times x to the negative 4th. The negative 4th is only applied to the x, so that's the only part that's switched, and so you can see it's in the denominator here. 0 exponent is the last one. So anything we have here, anything to the 0 power is 1. So we have x to the 0 over 4. Well, x to the 0 is the only part, that's going to be 1, and then it's all over 4. So here's a thing to remember. These power rules assume that the variable does not equal 0 whenever it's in the denominator or if it's raised to the power of 0. Alright, so here's some things you need to be careful with. These are some common misconceptions that students will make, and we want to make sure we don't make them. So if you look over here in the first one, we have a plus b to the nth. We kind of have seen this in the past, and we've addressed it in class, but you do not distribute that n to the a and to the b. That n is represented by you expanding. Okay, so a plus b times a plus b. So do not distribute. Okay, and so over here, a plus b on the second one over a plus c does not equal b over c. So just because you those a's doesn't mean you can just cancel out. That's when we get into common factors and things like that. So in this case over here, the last one, you don't cancel those 5's out and think it's going to be 2/3. Okay, so this is do not do that. Another one, this third one's very important too. Most students think that a to the 0 is 0 or just any number to 0 power 0. It does not mean that, okay? So your answer will always be 1. And again, we addressed that in the last page, 0 property rule. Okay, and then same thing right here. The negative exponents do not make a monomial negative. So that negative exponent does not make it the a, or whatever number in the case, negative. So if you see our example over here, 4 to the negative third is not negative 4/3, okay? So keep that in mind. All right, here's some examples of the different rules. So we're going to first start out with the product rule. So in this example, x to the 5th times x squared is x to the 7th. So again, this is product rule, says that we add the exponents. Number 2, we have 2 to the 4th times 2 to the 1st. So that will be 2 to the 5th. And then, of course, now most times when you have, something where like this, where you have 2 to the 5th, you could actually keep going and simplify to be 32, and we will want to make sure we'll actually simplify moving on forward. The third one, same idea, we're going to use our x's. Our x's, x squared times x to the 3rd would be x to the 5th. And then our y's, just the y and the y to the 4th would be y to the 5th. So we just add exponents. The second rule, quotient rule. Quotient rule says that we subtract our exponents. Now when we are subtracting, we want to make sure we always have a positive result. So this means on this one, x to the 5th over x to the 3rd, the answer would be x squared, and an x squared would be in the numerator, and the reason why is because 5 is bigger than 3, and that will give us a positive result. Okay, so number 2, when we're subtracting, x squared is up top, x in the bottom, so when we subtract them, we'll get 1x. Same thing for the y's. We'll subtract and we get y squared again. These are all in the numerator because we want to make sure our answers are positive with positive exponents. So our first example under the power rule says that we will be multiplying our exponents. So x to the 3rd times 2 would be x to the 6th. Okay, number 2, we'll be multiplying our 2 and our 3. So 2 squared times 3, so that'll be 2 to the 6th. And then we'll simplify that to be 64. Number 3, we'll multiply our 2's, our x squared times the 2, so that'll be x to the 4th. Y to the 4th times 2 is y to the 8th. Our negative exponent rules. Negative exponent rule says that we want to make sure our negative exponents are positive. So you can treat x to the negative 3rd over 1, and so our final answer will be 1 over x to the 3rd. We just switch places in order to make our exponents positive. Number 2, our exponent is negative in the bottom, so we're going to bring it to the top. Switch places to the numerator, and it's just y. Okay, so here's some combinations of everything. So on our first one, we are going to first distribute that negative 1 to our power. So we're going to have x to the negative 2nd, we're going to be multiplying, over y to the negative 3rd. Okay, so now we're going to then use the negative exponent rule, which says that we must make our exponents positive, so we need to switch places. So it's going to now say y to the 3rd over x squared. We can't go any further, so this is our final answer. Okay, so the second one. So when we're doing this, we will need to make sure we'll subtract our exponents, and we need to make sure our exponents are positive. So what I recommend is, you can go ahead and put all your negative exponents, switch the places. So in this case, we'll put the z to the negative 3rd to the denominator. So it's going to say x y squared all over x squared z, and then of course it's going to be now multiplied by the z to the 3rd. And so then we'll need to simplify. So we'll have z to the 4th in the denominators. We'll be adding our exponents. And our x's, we'll need to cancel those out. So we'll have just x in the denominator and then y squared in the numerator after we canceled our x's. So this is as far as we can go. And so we're done. Okay, so the next one, we're going to first distribute our 3 to everything. Every power gets multiplied by 3. Numerator and denominator. So the numerator will now say 2 to the 3rd, not 2 times 3, 2 to the 3rd, x to the 15th, and y to the 3rd. All over 4 to the 3rd, okay, x to the negative 6, and y to the 9th. Alright. So we want to simplify this. Now if you look here, our x to the negative 6 needs to be brought into the numerator. Okay, so we're going to now take our x to the negative 6 into the numerator, but now while we do it, I am going to also go ahead and simplify the 2 to the third, which is 8. So, okay, so the x to the negative 6 is going to be brought up, so now it's going to say x to the 21st, because 6 and 15 will have to be added, y to the third, over 4 to the third, 64, and then we have y to the ninth. Okay, so we have some more simplifying to do. If you look here, our 8 over 64 is a fraction in its own, so that will need to be simplified by itself to be 1/8. Okay, but then we still have our x to the 21st still up top. And then we got to finish our y. So our y to the third will need to be subtracted with the y to the ninth to be y to the 6th. So this is as far as we can go, and so that is our final answer. Okay, so I'm going to show this one other way of doing something where you're simplifying your exponents. Now, doing this could take time, but just to kind of recap, kind of what we're doing and why these rules work the way they do. If I were to expand everything, so we have our x's, we had 2 x's up top, we had 3 y's up top, and we had 5 z's up top. Okay, I just kind of rewrote them all out. 4 x's in the bottom, 2 y's in the bottom, and then 1 z in the bottom. So what's happening is, with your subtracting, you're adding your exponents, that kind of thing, everything's getting canceled out. So we can cancel out one set of x's, another set of x's. So if you see here, there are 2 left over, so there will be 2 x's left in the denominator. The y's, cancel out 2 y's. I have 1 y left over in the numerator. And then z's, I cancel out one set of z's, so I have 4 z's left over, so I have z to the 4th in the numerator. Because I know, again, a common misconception students will have is, they'll get the right variables, but the z to the 4th or the x squared are in the wrong locations of your fraction. So by writing them out like this, again, it is time consuming, but then you'll get it right every time because you'll have the exact variables in the exact place of your fraction.